Hi, welcome back. Dr. P here again, and in this lecture we're going to take a look at the mechanism of the SN2 reaction. Alright, so let's go ahead and take a look here. SN2 reaction has second order kinetics, and it has a bimolecular rate determining step. So, for example, if we had our CH3Br plus Cn minus reacts to give CH3Cn plus Br minus. If we draw our reaction progress diagram like we did last time, we'll start with our CH3Br and Cn minus, and then they'll collide with each other and form a transition state. And I'll show you what that looks like in just a minute. And then at the end here, we've got our product CH3Cn and Br minus. So the reaction is going to look like this. We will have our nucleophile here. So maybe I'll just draw it here. N triple bond C minus and we'll have our CBr H like so. Let me just zoom in here for just a sec. Zoom. And again, what we get is we get a nucleophilic attack. So this is our nucleophilic backside attack. And we also have loss of leaving group. And this happens all at once. Okay, we say it is a concerted mechanism. So it's just one step. So our nucleophile attacks, kicks off the leaving group, and we will end up with N triple bond C, C, H, plus Br minus. Okay, now let me move that so you can actually see it. There we go. Now what does this transition state look like? Well, what we'll have is we'll have our Cn coming in and forming a bond while the bromine is leaving. So the new CC bond forms while the CBr bond breaks. Meanwhile, these guys here are all in the same plane, and they're kind of, we've got one hydrogen sticking out, one sticking back. We're going to have a partial negative charge there, partial negative charge on the bromine, and a partial positive charge in the middle. Okay? So we get the backside attack, we form this transition state. So this species that's our transition state. So that's what exists up here. Let me zoom out again. that's what exists up here, where it's marked TS. Now, I thought it would be a good idea to make some models and show what this looks like. So here is the bromomethane, and here's my cyanide ion. And so what's happening is the cyanide ion is coming like this. Okay, this is the backside. It is opposite where the leaving group is. So we get backside attack. And so this guy comes in, and then these, the hydrogens, whatever substituents we have, other than the leaving group, are going to fold up and then fold over. And so when we're in the transition state, it looks something like this. Okay, where we've got our carbon from the cyanide, so we've got our nucleophile, our carbon from the substrate, and the leaving group all in a line. Okay, so these longer bonds there, this one's forming and this one's breaking. And notice that we've gone from having this tetrahedral structure to having a planar structure for the middle part here. These are all in the same plane, the 3 hydrogens and the carbon. So now these will continue flopping over, and the bromine will leave, and we'll end up with this guy in the end. And we refer to that as inversion. And that's a consequence of the, or rather, it's the stereochemistry of the reaction. So the stereochemical progress of the reaction, that is inversion, is due to this mechanism, the backside attack and the kind of flipping of those guys there. Now I could build another model just to sort of illustrate this, and I'll draw some structures later on, I think, in another video. But let's just say we had a couple different guys here. I'm going to do these. Okay, so if we started with this, and we have our nucleophile coming in, okay, we will proceed to this transition state. Okay, so we've gone from this guy, tetrahedral, to this guy, planar in the middle. And then the leaving group leaves, and then these substituents flop over. And so what we end up with is, we end up with this guy here. Okay, they've flopped over. And so if we look at these and we rotate them around to line up one of our substituents and then our leaving group with our nucleophile, we'll see that the other two don't line up. And if we were to go ahead and figure out the configuration, we'd see an inversion of the configuration from R to S or S to R. Okay, so that's something important to consider, and we'll talk a little bit more about that in a future video. All right. Well, until next time, stay safe out there. Bye now.